This video is prepared by Aavya classes. Please subscribe the channel, raise your doubt and watch the video for sure success in JEE, AIMS and NEET. So what is basically angle of friction? Angle of friction theta is the angle between normal reaction N and the resultant of limiting friction and normal reaction. Like consider this figure where an object is placed on a surface. So I have drawn the free body diagram of the system also. Here if m is the mass of body, then mg will act in downward direction. Normal reaction N equal to mg will act in upward direction. A force of friction is act in the backward direction given by mu n, while the external force F will act in the forward direction. Now if we consider the resultant of limiting friction value and the normal reaction, so value of limiting frictional force Fl is equal to mu mg, while the value of normal reaction is equal to mg. If we consider the resultant of limiting friction value and the normal reaction, so value of limiting frictional force Fl is equal to mu mg, while the value of normal reaction is equal to mg. We get the sum, or the vector sum is equal to s, which is making an angle theta with the normal reaction. So this theta is called as the angle of force. So how we will calculate this value of angle theta? So as per this figure, tan theta is equal to this force divided by this force. That is, as per this figure, tan theta is equal to F limiting divided by N, and F limiting is equal to mu into N. So divided by N, from there we get mu. So tan theta is equal to mu and theta is equal to tan inverse mu. So it is written here that the angle of friction is equal to tan inverse mu. Hence coefficient of limiting friction is equal to tangent of angle of friction. Now we will calculate the resultant force exerted by the surface on the block. So the resultant force is given by S here, and from this figure S is the vector sum of frictional force and normal force. So S is equal to square root F square plus N square. The value of N is mg, F is mu mg. So if we square it and add it, we get the value of S is equal to mg square root mu square plus 1. So clearly when mu is equal to 0, the value of S turn out to be mg. And as per this equation, the range of S can be given by mg. Range of S can be given between mg and mg into square root mu square plus 1. So it's written here that range of S can be given by mg and mg square root mu square plus 1. Now we will learn about next concept, angle of repose. So angle of repose is defined as the angle of the inclined plane with horizontal such that a body placed on it just begin to slide. Like if I see this figure, it's an inclined plane. If I place an object on it, and we can increase the inclination. So suppose we are increasing the inclination, then a point comes when this object will start sliding. So the angle at that instant will be called as angle of repose. So it is written here, it's a angle that object body placed on an inclined plane will just begin to slide. So by definition here, alpha is the angle of repose. So we will calculate this angle of repose. For this I have drawn the free body diagram of system. This mg force will act in downward direction. We break this force into components, mg cos alpha and mg sin alpha. This normal force is equal to mg cos alpha, and the frictional force acts in the backward direction along the plane. So at at the time of just start of motion, this mg sin alpha counterbalance this frictional force. So in the limiting condition, when the object will just start sliding, then mg sin alpha is equal to f, and it is equal to mu n, as the frictional force is equal to mu n. So from there we get mg sin alpha is equal to mu mg cos alpha, and from there we get tan alpha is equal to mu, and alpha is equal to tan inverse mu. So we have already learned that the angle of friction is tan inverse mu. Here angle of repose comes out to be tan inverse mu. So angle of friction and angle of repose are equal. So coefficient of limiting friction is equal to tangent of angle of repose. Angle of repose is tan inverse mu. Angle of friction is also tan inverse mu. Now is some problem based on the concept of angle of friction and angle of repose. So first problem is a body of 5 kg weight kept on a rough inclined plane of angle 30 degree starts sliding with constant velocity. Then the coefficient of friction is, assuming g is 10 meter per second square. So here the angle given is called as angle of repose. At it will start sliding at this angle, so theta is equal to 30 degree, and it is our angle of repose. And we know that tan theta is equal to mu, that is tan of angle of repose is equal to coefficient of friction. So tan 30 degree is equal to mu. Mu is equal to, we have to calculate mu, so mu comes out is equal to 1 by square root 3. So answer will be A. Now we will see next problem. A body is placed on a rough inclined plane of inclination theta. As the angle theta is increased from 0 to 90 degree, the contact force between block and plane. And 4 options, and you have to identify the correct one. So first we will draw the figure pertaining to it, and we will try to understand this problem. In fact, it's a very good problem. So this is angle theta. The object is placed on this inclination. The force of gravity will act in downward direction having value mg. If we divide it into 2 components, then mg cos theta is balanced by the normal force n, and mg sin theta will act along the plane, which will provide the necessary force for movement of this block. The frictional force also act in the backward direction. So now if you see that, as we know that till the angle of friction the object will not move. Like if you write here frictional force F is equal to mu n, and F is equal to mu mg cos theta, as n is equal to mg cos theta. So if you see here, then this object will not move till the frictional force is equal to mg sin theta. So when till tan theta is equal to mu, this object will not be moved. That is theta less than and equal to tan inverse mu, this object will not move. This, and at theta is equal to tan inverse mu, it will just start moving along the plane. So till the time it will not move, we will first calculate the contact force, and we will calculate the contact force when theta is increased beyond tan inverse mu. So what are contact force involved here? Here we have 2 contact force. One is the normal force and other is the frictional force. So if you add these 2 forces, or if you calculate the resultant of these 2 forces, then net contact force Fc is the vector sum of normal force plus vector sum of frictional force, and Fc is equal to square root n square plus f square. That is mg cos theta square plus mg sin theta square. As it is very clear that till theta is less than tan inverse mu or theta equal to tan inverse mu, frictional force is equal to mg sine theta. So from there we get the value equal to m square g square square root, that is equal to mg. So till the time theta less than and equal to tan inverse mu, the contact force is equal to mg and it is a constant quantity. Now if I increase theta greater than, if I increase theta further, that is theta greater than tan inverse mu, then we will see what will happen. In this case the normal force will be equal to mg cos theta, and the frictional force F is equal to mu mg cos theta. Frictional force is equal to mu n. Now the frictional force will no longer be equal to mg sin theta. Mg sin theta will be more than the frictional force, and because of this object will start sliding. So basically if you see here, then the contact force Fc is equal to m square g square cos square theta plus mu square m square g square cos square theta. That is, if I take mg cos theta common, then it will be equal to mg cos theta square root 1 plus mu square. So the contact force now will be equal to mg cos theta square root 1 plus mu square for theta greater than tan inverse mu, and for theta less than and equal to tan inverse mu, we have contact force is equal to mg. So if I plot this graph, then this is the changing value of theta, and till theta is equal to tan inverse mu, the contact force is equal to mg. This is y-axis we are plotting contact force, on the x-axis we are plotting theta, and afterwards we will see a cosine curve. So this is a cosine curve, value equal to mg cos theta square root 1 plus mu square. So this is the basically graph. Now we will see the options. Then first remain constant and then decreases will be our answer, that is answer will be B. Now we will see next problem. The upper half of an inclined plane of inclination theta is perfectly smooth while the lower half is rough. A body is starting from rest at top comes back to the rest at the bottom if the coefficient of friction for the lower half is. So first I will draw the figure. Consider the object of mass m is placed here, and for the first half, that is for the BC, mu is equal to 0, and for the AB, consider the coefficient of friction is mu. The angle theta is given here. So angle theta is given here. It is given that a body is starting from rest at top comes back to rest at the bottom. So you have to calculate the coefficient of friction. We will study the motion of two halves separately. So for upper half of the motion, that is for BC, your initial velocity is equal to 0. We have to calculate the final velocity. The acceleration is equal to g sine theta. So if a block is placed here, then the mg will act in downward direction. We will break this mg into two components, mg cos theta and mg sine theta. As there is no frictional force, so only normal force n will balance mg cos theta, and we have an acceleration equal to mg sine theta along the plane. So based on this, we calculate v square is equal to u square plus twice as, considering s is equal to L by 2. If we consider the full length of this plane is L, then BC is equal to L by 2. From there we get g sine theta into L, and v is equal to square root gl sine theta. Now we will consider the second half, that is for AB. for motion along AB, we have acceleration. First we will calculate acceleration. So here we have one frictional force will also be act, and mg sin theta will act along the plane in downward direction. Mu mg cos theta will be the frictional force which will be act along the plane in upward direction. Mg cos theta will be balanced by the normal force. So the net acceleration will be here A net is equal to mg sin theta minus mu mg cos theta. If I divide it by the mass m, then we will get the acceleration. So acceleration is g sin theta minus mu g cos theta, and from there we get, for motion along AB, the final velocity must be equal to 0 because the body has come back to rest at the bottom, and initial velocity u is equal to a square root gl sin theta. So we will apply again the formula v square is equal to u square plus 2as, and the value of a is equal to v is equal to 0, u square is equal to gl sin theta plus 2a is equal to g sin theta minus mu g cos theta into s is equal to l by 2. So from there we get it's equal to gl sin theta plus gl sin theta minus mu gl cos theta. Here we get 2 sin theta is equal to mu cos theta, and tan theta is equal to mu by 2, and mu is equal to 2 tan theta. So you have to calculate the value of mu. So mu is equal to 2 tan theta. Option D is correct.